Okay, so here we have another problem where we have to identify if this function is going to converge or diverge, and if it converges, we need to identify what the area is going to be. So here I look at this, and it's kind of challenging immediately for me to see how we can integrate, right? Find the antiderivative of this function. So I'm just going to write it again. So maybe if I write it again, it's going to help me identify. Okay, so when I look at this, I'm like, what can I do? So if I set u equal to x squared, let's see what happens, right? U equal to x squared, that means du is equal to 2x. We don't have a 2x somewhere here. We can't really use anything. It's not gonna be something that we can do. Next thing I think about is the exponent. So let's try that equal to u. So u is negative 1 over x. If this doesn't work, perhaps u substitution is not the best way to do this. So du ends up being negative, so this is equal to actually negative x to the negative 1/2. Du ends up being negative, we bring this negative 1 down, which is making it going to be positive, and then x raised to the negative 1 minus 1, which is negative 2. So this is equal to x raised to the negative 2, which is also equal to 1 over x squared dx. We have that, and this is how we solve the problem. So we have to first look if we have to look at all the possibilities before we move on. So limit as b approaches to infinity, this is b, this is 1, e to the negative 1 over x is just u, so this is just e to the u, and then 1 over x squared dx is just du. This is very easy now. Remember, we have to identify if we can use u substitution. We have to make sure that we are looking at all the possible integration techniques before we move on. Get rid of this. Alright, so this is just going to be equal to the limit as b approaches infinity. And I forgot to change the bounds of integration. We have to do that. So this is just going to be b, instead of b, let's make that negative 1 over b. Instead of 1, let's make this negative 1. Okay, cool. Alright, so that's that, and so now we can write this again. So e to the u, the antiderivative is simply e to the u. That's very easy. Then we can plug in negative 1 over b and negative 1, and this is equal to the limit as b approaches to infinity of e to the negative 1 over b minus e to the negative 1. Okay, this is just equal to the limit, so we can split this into two limit problems here. So negative 1 over b, and then minus limit b approaches to infinity of e to the negative, or 1 over e. Let's just write that. This is just a constant right there. So this is simply the limit as b approaches infinity of e to the negative 1 over b. So as b goes to infinity, this is just going to become 0. So e to the negative 0, that's just 0. Anything to the power of 0 is just equal to 1. E to the 0 is 1. That's nice. So this is just going to be minus, and then 1 over e, b, limit as b approaches infinity of 1 over e, that's just 1 over e. And so this is actually all we have. We can obviously, if we want to, make this 1 over 1 multiplied by e over e. So this is just e by e minus 1 over e, which is e minus 1 over e. It's the same thing. Okay, that's it. This tells me that this is going to be convergent. And that's our area. I hope you found this video helpful.